Biomimicry is an effective tool in helping our students develop their critical and creative problem solving skills. Biomimicry really focuses on bringing those thinking skills we want our students to develop into the forefront of the classroom. And biomimicry opens up our students' eyes to possibilities. Biomimicry is an approach to innovation that seeks sustainable solutions to human challenges by emulating nature's time tested patterns and strategies. And for our students, biomimicry really helps develop questions and curiosities. It's all about the real world and having our kids look deep and look at the possibilities and problem solving that they can take part in. A lot of people know biomimicry. When you think about what led to the development of Velcro, burrs that were caught on scientists' pants legs. But also, scientists have been able to use the shape of bird wings to help them improve the shape and effectiveness of jet wings. There's a great story about how the Olympic swim team was able to improve their speeds. And it all began with a swimsuit developer who was examining shark skin to figure out why sharks could swim so fast. All of these, items began with someone looking deeply at nature. And that's what biomimicry really provides. Nature has these answers, the systems that have survived for thousands of years. And for kids to really look at that and consider that as a way of designing new ideas. One of the first steps in getting especially young children involved in biomimicry is providing them with the time and space to actually get out in nature, to break down our classroom walls and start looking at the world around us. And sometimes it's just the quiet walk where students are seeing things and we're not looking at the entire forest, but really trying to find small things. Why does a stump disintegrate? How do leaves, just break down? How does water clean itself? How do trees feed itself? Something that's been really on scientists' minds have been pollination and the impact on world food sources. And when you start to look at kids and help them get outside and look at gardens and figure out how to produce food, pollination becomes a real issue. And giving kids the tools to create hand pollinators, to look at things and to say, what if there were no bees? What would happen? And how can we make sure that that doesn't happen? A lot of my students have used a biomimicry lens when examining water. Water is part of our science curriculum, especially in the younger grades. When kids get their hands on the actual objects, for us to get into water and look at it, one of the most important things for, children in New Jersey is to understand the value of water. They've never had to question where their water comes from or if their water is clean. So, in looking at global water, all of a sudden kids start to say, is this a problem? Is this a problem that could impact my life? And, for kids to say, how does nature clean its water? There are systems in place that even when human beings pollute water, there's certain places and certain end results that, have clean water. So having kids think about this, design ways that change their minds, and to have, this was a biomimicry project on cleaning water, but, thinking like waves or thinking like a stream or thinking how does, a river with rocks end up actually cleaning pollutants out. Giving kids the space to have a lot of opportunities, those hands-on learning opportunities, which will lead them to make mistakes as well. Maybe their idea doesn't work as well. Maybe an irrigation approach that they think is something that has been successful out in nature ends up not being very successful. Or maybe it does. This young man actually ended up being able to figure out how to get all that dirty, oily, mucky water into fairly clean water. Over and over again, he made the system work better and better. And providing kids reflective time after you do these experiments, after you dive into biomimicry. How are you going to tell someone about it? Is it words? Is it pictures? Is it technology? Hands on problem solving helps develop creative habits and attitudes. How important it is to think with flexibility and fluency, that curiosity leads to action, especially when we are looking at nature as our influence, as our inspiration. Again, collaboration, working creatively with others, thinking critically, listening attentively, implementing innovation, and looking for multiple inspiration. It may not be one thing that leads to a solution, but the melding of many ideas, and then being able to justify, support your idea, and of course thinking with perseverance. With very, very young children, it's often time that they need to just observe and think, how does this look? How does this compare to something else? These are some watercolors of my young students just observing animals and considering their attributes. And here's one of the little guys who had a biomimicry kind of tilt on his observation. If headphones were shaped more like owl's ears, would we hear better? That's something that, he might not have considered before. When we put our observations together, when we are working, in tandem, kind of really structuring, your idea is better when it combines with my idea, and so on and so on, and getting our kids to talk to each other. When we're looking at nature and looking for solutions, we need to be open to lots of ideas. Using some sort of literature to kick off your biomimicry approach, and all of a sudden looking at different ways. What is the role of roots beyond just delivering nutrients to a plant? Could we use them to structure different kinds of, growing gardens? And then sharing your knowledge. If kids really become experts in their one view or one idea of biomimicry, providing opportunities for them to share it is really important. Technology opens up so many avenues for that today, to explain an experiment, to explain a project. And to have a flood of ideas is so valuable. Getting kids used to mind mapping, looking at different ways. And again, really utilizing these tools. We have these amazing tools that enable our children to not only, be consumers of content, but to be creators. And if they are working on a project such as an animation to explain their biomimicry theory about cleaning up an oil spill, providing them where, some avenues to share it is really important. Developing games, developing presentations, and just starting to have them think of the problems that are all around us, plastic, recycling, looking at different ways. All of a sudden kids are like, wait a second, here's a connection I just saw. This hive can be utilized as a building material or a structure for building. One time we were looking at just how a hive can be created and how we could turn that into something in our classroom. And a student found a building project utilizing those same plastic bottles in a hive-like pattern to be able to, create a whole village. Just having kids go outside and do something they've never done before. These kids were literally spending time watching birds fly. And when you really only focus on that, you start to see things you've never seen before. And then coming back and building, another way of making a flying machine based on what you know about birds' wings, and changing it. These projects are not expensive, they are not time consuming, they're a way of making kids think. And then from one flying machine, you go to another, and then share and ask and engage experts and talk about ideas. Always asking both the why, but also the how. Using biomimicry as a starting point encourages the things we want from our gifted students who are showing those creative, curious abilities, but also it is the kind of a framework where everyone can strengthen their questioning, their ability to challenge ideas, to be comfortable with imagination. Why not? How is that done? And again, justifying, persevering. But it all starts with hands on, building, questioning, working together, talking, and having evidence of a project. People say, okay, I'm going to spend a lot of time on a biomimicry project. How am I going to know it's effective? How am I going to know the students learned? Well, they will develop portfolios, they'll have self reflections, they will write the narrative of their story, and they will work together because together we're stronger than alone. Scientists, designers, engineers, they work in teams, as our students should be, constantly sharing their knowledge and asking, will this work? How could we look at nature in a different way? How can I look at the systems that exist and have it impact my work? Giving our kids the time and space and materials to really, start to be an engineer, a designer, a scientist, someone who is familiar with biomimicry. And sometimes it literally starts with just a whole pile of stuff and letting them engineer and invent solutions. If you are interested in learning more about biomimicry, there is a great resource online. It is the Biomimicry Education Network. You will find videos, you will find some amazing work that scientists are doing, with robotics, in the ocean, in the air, with pollination, as I mentioned, with recycling, with sustainable STEAM activities. So please check that out. You'll find a lot more information. And if you do have any questions or comments for me, my name is Jean Musi, and I am available, and I'd love to talk to you more about biomimicry. Thank you very much.